each site, we put a bird survey point at 100-meter intervals right along the center of the riparian woodland. Those blue dots are groundwater, existing groundwater wells. This is a closer up of lower Las Cienegas, and again, these are those points, survey points along the center of the riparian woodland. But at a subset of 4 of our 29 survey routes, we also did a series of 2 upland routes that were immediately parallel to the woodland route, and lower Las Cienegas was one of those 4. And so at 200 meters upland from the riparian strip, we had our first upland transect, and then at 500 meters upland from the woodland, from the riparian strip, we had a second upland transect. And so again, we did this at 4 sites. This is just one of them, and I'll show you some results of that. We did that to quantify this issue of how important riparian areas are to local biodiversity in birds. So let me just quickly talk about the bird surveys. We did surveys in these 29 riparian woodlands throughout the region. So we surveyed a total of 337 survey points, so it was a fairly large study. We conducted at least 4 surveys during the breeding season at each one of those 337 points. Many of these sites we surveyed multiple years. And then at lower Las Cienegas, we've been doing late season surveys to pick up, in addition to those 4 quote-unquote breeding season surveys, to pick up yellow-billed cuckoos and some other species that typically arrive late. And again, I just mentioned we surveyed these 2 parallel transects at 4 of our sites. At each one of these sites, we also measured the amount of surface water immediately after each survey, so we could look at seasonal change in surface water and amount of surface water across the season at each site. And so we estimated the amount of surface area of each individual surface water pool, or if it was a continuous stream, we measured the entire stream length. So at each one of our survey points, we were able to quantify the amount of surface water within a 50-meter radius around each survey point and how that changed throughout the season. So we did these surface water measurements every 3 weeks, and we did them during the winter as well. And to summarize those surface water variables, we basically came up with 2 variables. One is the average surface area of the surface water. So that's just that's pretty straightforward at a point. So average meaning we're visiting these points numerous times throughout the breeding season. So we just took the average amount of surface water in the 50 meters surrounding each point. The other variable that we're interested in is the number of visits with surface water present. So the number of the 4 visits each season, how many was there any surface water available? I keep wanting to go over there to push this, and I keep forgetting I have this in my hand. This is just a very quick graphic that shows our what we call our wet sites, or our perennial sites. These are our intermittent sites, and these are our ephemeral sites. And this is the change in the season with the average amount of surface water. So you can see these perennial sites, like I say, they stay wet year-round. And these intermittent sites typically have water early in the season, and they dry out in June, right before the monsoon. And these dry sites are basically dry sites. And I put that out there just because we had to classify. We tried to classify these sites in advance before we collected this data based on just regional knowledge and talking to agencies and landowners. So we actually had a few sites where we had to we tried to get them equally dispersed, but it turned out what we thought was a dry site was an intermittent, and vice versa. See, I keep going over there. And then we also estimated we did very arduous estimates of vegetation structure at each one of these 337 survey points, because again, we wanted to look at the effects of surface water independent of the vegetation, because we wanted to look at really short-term effects with reduction in surface water, even if there's no change in the vegetation. And so we quantified vegetation at understory and midstory and overstory, different height levels. Also, at a subset of 11 of our wet sites, 11 of our sites, we did extensive arthropod sampling using sticky traps. So these are airborne invertebrate sampling. We put sticky traps at ground level, at midstory, and at canopy level, and we interspersed these along the riparian woodland transect. Again, we did those at both dry sites and wet sites. And so for the analysis of this large data set, we had 44 different vegetative structural measurements. And so that's just way too many to start developing models. And so we first used factor analysis, which is a way to reduce a large number of correlated variables into independent factors that are a kind of an accumulation of individual variables. So with that, we were able to reduce these 44 structural vegetative features into 11 factors that represent vegetative structure at different scales. And then in addition to those structural factors, we included a variety of other variables like latitude and the width of the riparian vegetation at that point and so on. And then we developed a suite of models. We used linear mixed models to account for the fact that our points were nested. We had 337 points, but they were nested within our 29 plots. And then we used information theoretic approach where we developed models and evaluated them using AIC. So just a summary of the results so far. We've detected over 240 species at, I should say, 29 sites, sorry. And since Karen invited me here, I also did some summaries of just the our two Las Cienegas sites. So we've detected 130 different bird species just at those two sites, which is really incredible. This is just at the two Las Cienegas sites. These are the top 10, the most abundant species at these two sites. Yellow warbler was the most abundant, and so these are the top 10. I've highlighted these yellow ones because all 5 of these species are species of conservation concern, either nationally or regionally by U.S. Fish and Wildlife Service, Arizona Game and Fish, or the American Birding Association. So it's really incredible. I've worked in a lot of different environments, and to have 5 of the 10 most common species in an environment be species of high conservation concern is unique. It's incredible. So it just gets back to the importance of these areas. And then a couple other species of note. 16th most abundant species of brown-headed cowbirds, which heavily parasitized some of the species in these areas. And then the greyhawk, which is also a species of conservation concern, was number 18. Again, these are just for our two study sites at Las Cienegas. So here's the data for our riparian, our 200-meter and our 500-meter plots. This is species richness, maximum number of species detected. So riparian areas support almost over double the amount of birds just 500 meters away from those riparian areas. Relative abundance is even more or equally strong. Our riparian areas support a much higher abundance than in the adjacent upland. Not really a surprise to birders, but it's important to quantify so we can argue for the value of these areas. This is just a representative species showing you the decline. There was a handful of species that showed the opposite pattern. Black-throated sparrow was the most obvious, but there was really only, out of 100 or more species, there was only about 4 or 5 that showed this kind of opposite pattern. So then we did this modeling approach, first looking at the community level patterns, species richness and relative abundance. I won't go through how we developed our suite of candidate models, but here are the 5 most well-supported suite of candidate models explaining relative abundance across all 29 sites. And the number of visits with water was in the top model, and it's also in 3 of the top 5. So in other words, even after controlling for vegetation, the amount of surface water itself adds predictive capacity. This is relative abundance of breeding birds, same message. Presence of water helps predict or increase abundance of breeding birds. Species richness the same. There's only one model that had a high support, and again, it has the number of visits with water and a lot of interactions with water. So then we went and developed a candidate, did the same thing on a species by species basis. We developed models based on the literature, and then we added a corollary model that included water. So a publication might say yellow warblers prefer this vegetative structure, this structural feature, and this structural feature. So we created a model with those three variables, and then we added another model that had those three variables and surface water, so that we could again look at the effects of surface water by itself. Yellow warblers again, the width of the riparian vegetation and our two water variables were in the top models. Same with yellow-breasted chat, same with song sparrow. Anyway, we did this for 100 species, so I'm just giving you these a representative three. And lastly, we looked on our vertebrate data. We also measured water stress of trees using a pressure chamber, portable pressure chamber that measures water potential in the stems. And so trees at dry sites had fewer invertebrate abundance on them. Trees at dry sites had greater water stress. Water stress increased as you moved further from the riparian area, and the water stress was negatively correlated with invertebrate abundance. So we have kind of a mechanism that, in summary, we have strong evidence that surface water by itself, independent of the vegetation, is positively associated with bird abundance and species richness. And at the species level, it also has an influence. I won't go through this. These are just model average parameter estimates that show that the water variables are one of the strongest variables in these models. And with that, I better end, and I've already gone over. Yes, I think the question is, what I presented shows this link between riparian areas, and in particular the amount of surface water in the riparian areas with bird abundance and species richness. But what about groundwater pumping and its link with surface water? Is that what you're asking? So each watershed, the answer to that's going to be different. It's going to differ depending on where the pump is relative to the riparian area. It's going to differ depending on the depth of the groundwater table and the topography and the geology of the watershed. So it's a something, in my view, and talking to hydrologists, that's where I've gotten my view, is that's a complicated thing. You can't just say this is what's going to happen to the surface water if you pump this much groundwater out of some watershed that we've never studied that. So the Park Service knew that, and for them anyway, they have a hydrologist who's answering that question within Rincon Creek. So the hydrologists are going to get the answer to say, okay, if you pump this much groundwater, this is what's going to happen to the surface water in Rincon Creek. And then they're going to use my data to say, and then given that, this is what's going to happen to the birds if this permit is allowed. Does that answer your question?
Well, I guess the thing I'm thinking is the first part of you.
I'm not an expert in groundwater hydrology, and so I can't assess your point. But from what I understand, I don't think it's any more difficult than any other problems we face from a scientific standpoint. I think a hydrologist will be able to tell you that. But again, what they'll say is, my answer in Rincon Creek is very different than my answer in Lower San Pedro, and it's very different than my answer in the Santa Cruz. And so, but it's not really that difficult. It can be done. It takes money in each area to have a hydrologist figure that out for you. But they can figure out, if you put a pump up there and you pump this much out of it, they'll be able to tell you what, or, you know, they'll be able to estimate, they'll be able to predict what the effect of the surface water in the riparian area is going to